Hi guys, welcome to the lecture number 5 of our PyTorch series. I think the PyTorch series is going excellent. So guys, today we'll be talking about tensor dataset and data loader in PyTorch. I think this is the essential element because I think now we know a little bit of basics. We have done regression in PyTorch. We have understood a little bit of backpropagation, and then obviously we'll combine everything into a good end-to-end project. So guys, the first thing is I just want to give you a quick process reminder on how do we create synthetic data sets in PyTorch. So it's a simple function definition. So this function is something that you need to understand a little bit. Torch.random. So you would have random features and there you would pass the number of samples that you want, and you here we are passing in 2. So we'll have 2D features. So we'll have about like columns like this. We'll have 1,000 rows over here. Okay, I think you're able to understand. For the time being, consider I am taking it as 1,000, and we'll have two columns over here. So let's assume there is 0.3, 0.2, and similarly you will be able to make it. So I hope you're able to understand torch.random. So it is able to generate some 2D random features. Yes, and we are using torch extensively in our course, so that's okay. Let's just move ahead. Let's just try to understand what we are doing here. So we are not doing anything, guys. It's just a simple this is a simple linear classifier which I have built, and like it's not a model linear classifier, it's a simple classifier that if the output is greater than 0, so go for a level 1 else 0. So it's simple, guys. If you understand this x, this, what is this? This is very important, guys. Let's just try to see this. So this is how our x are going to look like. Okay, let's assume we just have about uh, 10 samples and we are just printing 5. So you will have 1, 2, 3, 4, and 5. So that's there. Then we are printing x of 0. So see guys, we are just printing this one, this to this. So 1, 2, 3, 4, 5, this and this would match. And then extensively we are printing the next 5 as well. So we are just printing the first column, and similarly I'm printing the second column as one as well. So this is index 0, this is 1, so this is 1 and 2. I hope you understand this much Python indexing. And guys, we are just adding them up, and if the number is like greater than 1, so we are assigning it a label 1, else we are assigning it a label 0. So I think you are able to understand. This is a simple linear classifier. Now guys, a quick note on basic data pre-processing. It's just we have been using standard scalar, so all of you know, but I just thought of giving you a quick reminder over here. It's simple, guys. The formula is this: x minus mu divided by standard deviation, and yes, we are adding some sort of epsilon to it, so that if standard deviation is very small or tending to 0, and sometimes due to floating point conversion and all, the denominator doesn't become 0, so we are adding this element. So I think this is relatively easy. You don't need to like remember anything, but just keep these things in mind. So now let's come to the main part of our lecture. So what we are doing, first of all, guys, try to understand. I'll be teaching you specifically in this lecture data loader, but the first thing is, without learning as well, let's try to see why do we need a data loader. So first of all, guys, loads large data sets in small batches. So last time, if you remember, we did mini batch gradient descent. So our data set was of 1,000. We broke it down into mini batches of 32, and then in one epoch, when 1,000 rows would pass through the entire neural net, it would happen in batches of 32. Just try to understand this. Why we need to do it like this? Because guys, see, once you will be having very large data sets, like, so loading everything in memory would become very difficult, so we do training in mini batches. And then guys, there is like few evidence which believes that, hey, if you train neural nets on mini batches, the convergence is better. Okay, some cases it might happen, some cases it might not happen. And yes guys, obviously if you are a data scientist, you would might have faced this situation. I face it a lot. Whenever we try to do any sort of operations on a data set, on a data frame, usually we work with data frames, right? So at times we do some sort of operations, but once we have to write it back to the original data frame, right, keeping a track of indexes becomes tough, right? So all these things are automatically handled by data loader, guys. You don't need to do anything. If you'll see, the code is very simple. So in the entire class I've been talking about torch.float tensor, right? So we need to use tensors. They are the building block of PyTorch. They work exceptionally well when it comes to GPU support, so we need to use it. And floating point, I think you understand this much, right? We need weights of the neural net to be in floating point. Then guys, see, we're just creating a data set by combining both of them. It's just a function that you need to call, and then this is the main data loader. So once you create this data loader, see how simple it is to create a data loader. Just need to pass one parameter, that batch size, and shuffle equal to true, so that in every iteration things would shuffle and randomness would be there. Now the main thing is there is no code involved. Okay, this is just one line of code, but if you'll see the impact of it, right? See, without I want to make you understand, because guys, syntax and now and everything can be generated by chat GPT and other AI models very nicely, and PyTorch, they work in like they work very extensively well. So I'll just close it once, and I'll switch to CPU only because I'm not consuming it. So guys, it's very important to, I'll rather disconnect, I'll go to runtime, and I'll interrupt, no, not interrupt execution, I'll change runtime, I'll make it CPU, because guys, if you're not using GPU, you should not do it, it's fine. So the main thing is you just need to understand this line of code and everything would be crystal clear. And as I said, that it's just one line of code which I just showed you. But the main thing that you need to understand is how does using data loader help. So see, we had sample of 1000, now we have batch size of 32 and number of batches as 32. Why guys? Try to think about it. Do 32 into 32. Okay, what is 32 into 2? It's 4, it's 6, it's 6 and 9. 4, 2, 1, 10, 0, 2, 4. Okay, so you have about 10, 0, 2, 4 number of records would be there, but everything, it would just have been rounded off or something else would have happened over here. But the main thing is that whatever extra record are remaining or whatever doesn't come into your batch size, right? So if you're passing it into 32, so there would be some remainder, right? Because 1000 is not exactly divisible by uh, 32. So whatever is remaining, PyTorch will automatically take care of it. So every time you use a data loader, you would find out that your mini batch training process, right? In the previous lecture, I showed you mini batch training process. That would become very simple. And guys, this is how you need to use it. It's simple. You just need to wrap X and Y inside a data set, tensor data set, and then you need to create a data loader like this. Rest you will later on see on how do we get that stuff into the neural network in the form of training format. So guys, in the next lecture, I'll try to come up with some interesting dummy use case where we'll combine everything into one go. We'll combine our data loader, we'll combine everything, and let's just see how do we build a good system. So on that note, I would like to end. Enjoy and have a great day, and please subscribe to my YouTube channel.